Hello everyone, myself Vinay Kumar M. So I am actually pursuing PhD in physics. So in this particular YouTube channel, I will be teaching physics, chemistry and mathematics. So if you want to learn physics, chemistry and mathematics starting from 8th standard till 12th standard, then please do subscribe to my channel and stay tuned with my channel. So the previous video was on 4th chapter which was there in this 8th standard mathematics subject. So this 5th chapter which is there in this 8th standard mathematics subject is squares and square roots. So to learn square and square roots, you should actually remember the word square. So what do you mean by a square? So in previous chapter I have done quadrilaterals. So in that quadrilateral chapter you have learnt about squares. Squares are those quadrilaterals which have equal length and breadth. For example, if this is a square, it has like 4 sides in it where all its sides are equal and all its angles are actually equal. Since all its sides are equal, if you calculate the length of this particular square and breadth of this particular square, then L into B, so that is actually length into breadth, will actually account for square. So that shows square is something which has its length and breadth same. So if you make length into breadth, you will get area of this particular square. So here, since length and breadth of this particular square are equal, you can either say it as L into L or B into B. That means either L square or B square. So here L square will be equal to B square will be equal to A. That means you are actually multiplying the same number 2 times to calculate the area of that particular square. So just by taking the length of square, you are actually multiplying that with itself because length is actually equal to breadth. So there how the word square has emerged, because square, in square, length and breadth will be equal. So always when you calculate area of that square, you will actually multiply the same number twice. So that's why if you multiply any number twice with itself, then that will be a square. For example, if you have a number 2 and if this particular 2 is multiplied with 2 only, then the answer will be 4. So this particular 4 will be a square number, like perfect square number. So let us discuss about perfect square also in this chapter. So first let us understand what is square. So square, as the name itself tells, that something which is having length and breadth same. That means something which has length, when it is multiplied with breadth, you will get the area where length and breadth are equal. That means you are multiplying the same value 2 times. So that's why this particular square is actually known as square, because it is actually using the same number, it is actually using the same length 2 times. So it is actually multiplied 2 times. So that's why the square which you are getting, the value which you are getting after multiplying the same number 2 times with itself, so that particular number will be the square of those 2 numbers. For example, 2 square will be 4. That means this particular 2 into 2 can be written like this, 2 square. So this is actually the power position of a particular number. So if you write any number like this, so this will act as a base. So if you write anything on top of this, like just right hand side corner of that particular number, so your right hand side corner, so for that number, if you write a number, that will actually indicate the power of that particular number. What do you mean by power is the strength of that particular number. So for example, if I write 3 power 1, then the strength of this particular 3 is only ones. So now if I write 3 square, that means strength of this particular number will be 2 times. That means the same number should be multiplied 2 times. That means 3 should be multiplied with 3. That means 3 should be multiplied. Same number should be multiplied 2 times. Similarly, if I take 3 on the power, so let's say this is base and this is power position. So in the power position, if I am taking 3, then that shows that particular number has power 3 times. That means that particular number should be multiplied 3 times with itself. So that will actually give you 3 into 3 into 3. So what is the value of 3 power 1? That is 3. What is the power of 3 square or 3 power 2? That is actually 9. So this is actually known as 3 power 2. This is known as 3 power 3. That means that particular 3 number has that many power. So it has that much strength in it. So here you are actually multiplying 3 into 3 into 3. That shows 3 3s are 9, 3 3s are 9 3s are 27. So now you can see the power of 3 power 1, it is actually 3 power 1. Since this 3 has only 1 in its power, the result will be just 3. So now this 3 has 2 in its power. Now the result will be 9. So now this particular 3 has 3 in its power. The result will be 27. So you can see 9 is greater than 3, 27 is greater than 9. That means the power of that particular number is increasing as you increase the value which is there in the power position. That shows how much power that particular number is having. So that's why we will actually call it as power. So some number you are taking and you are actually giving some power to that particular number. So for example, if you are just taking one number, so by default it will be having power 1. So let's say if I take 1, 2, 3, then this 1 has power 1, this 2 has power 1, this 3 has power 1. So any natural numbers or any kind of rational numbers or any numbers when you take, so if there is nothing in its power, then by default 1 will be there. So if that particular number has power 2, then it should be multiplied 2 times. If that particular number has power 3, then that same number should be multiplied 3 times. For example, 3 power 3 will be having result equal to 3 into 3 into 3. So like this, power will actually give certain amount of strength to that particular number. So that's why we call it as power. So here also you can see 3 power 3 has more power than 3 power 1, because 3 power 1 will be having just 3 as its answer, but 3 power 3 has power like the answer equal to 27. So 27 is much more greater than 3. So here you can actually analyze how power works. Here you can actually analyze how squares and square roots you can understand through this, because any number which has 2 in its power, then that will be the square of that particular number. That means, for example, if I am doing 3 power 2, then this is actually known as 3 square. Just because 3 is multiplied 2 times by itself, it will actually give the area of a square which has its length equal to 3 centimeter or 3 meter. So that actually shows why the word square has emerged. So this is all about squares. Based on this particular squares, you have some properties which is connected to squares. So let us go on discussing the properties which is there in this particular squares. So coming to one particular property of this particular square. So whenever you take square of any number, let's say 1. So if you take square of 1, it will be 1. So if you take square of 2, then it will be equal to 4. If you take square of 3, then it will be equal to 9. If you take square of 4, then it will be equal to 16. So any number, like when you see this particular number, these are all ending with either 0, 1, 4, 9, 6 or 5. Because when you do 5 square, you will actually get 25. So if you take square of any particular number, then the square number will have these numbers in its units place. So for example, if you are taking 16, this 16 has 6 in its unit place. So if you take this 25, this 25 has 5 in its unit place. That means 0, 1, 4, 9, 6 or 5. So any one of this particular number will be there in the unit place. So these numbers will be there in the unit place for a perfect square. So let us discuss what is perfect square now. Because whenever you take a number and if you find square root of it, then you should always get a natural number. So you should always get a complete number. You should not get in terms of decimals or in terms of rational number. So for example, if I give you the number 10 and if you take square root of 10, you will not get any number which is actually complete or which is actually natural number. So if I give 9, then if you take square root of 9, that will be 3. That means this is actually the root of this particular square. So in my next video I'll be discussing about square roots. As of now we will just concentrate on squares. So here, to get 9 as a square number, you are multiplying 3 two times. So you should actually increase this particular 3 with power 2. So 3 square will be 9. So 9 is a complete number. 9 is a complete number. 3 is also complete number. Complete number means natural number without any decimals or without any fraction involved in it. So now if I take 3.2 into 3.2, then you will get certain number. Or when you actually calculate the square root of a particular number, let's say for 9 you are calculating square root, then square root will be 3. So similarly, if you calculate square root for 10, so square root you will get in terms of somewhere around 3.1 or 3.2 or 3.3 like this. So this actually shows that the square root of a particular number is in decimals or it is in fractions. Then that particular number is not a perfect square. Only two natural numbers when they are multiplied with each other and you are getting a whole number. So only when two whole numbers or natural numbers is multiplied and you are getting another natural number or whole number, and if you take square root of a whole number, if you take square root of a natural number and you are again getting a natural number or a whole number, then only that particular number will be a perfect square. So here 9 is perfect square, 25 is perfect square, 16 is perfect square, 4 is perfect square, 1 is perfect square, because its square root has natural number or whole number in it. So here square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, square root of 16 is 4, square root of 25 is 5. So that shows this particular square root is not in the form of decimals or it's not in the form of fractions. So that's why this 25 will act as perfect square. So this is what the explanation for perfect square is. So if a particular number is ending with 1 or 9, so if a particular number is ending with 1 or 9, just like if you take square of 1, 1 square will be 1. If you take square of 9, 9 square will be 81. So if you take square of 11, 11 square will be 121. So if you take square of 19, then the answer will be 361. So this shows any number which is actually ending. So these numbers which you are actually considering are all ending with 1 or 9. So 1 is actually ending with 1, 9 is actually ending with 9, 11 is actually ending with 1, 19 is actually ending with 9. So any number which is actually ending with 1 or 9, then its perfect square or the square number will also end with 1. So square number will be ending with 1. So if square root is ending with 1 or 9, then square number will be ending with 1. So that is what you can observe here. So here this particular number is ending with 1, this is ending with 9, this is ending with 1, this is ending with 9. So here also if you take one more example, if you take 21, then the answer for 21 square will be 441. Here also this particular 21 is ending with 1. So here also you can see 21 square, the square number of 21 is also ending with 1. So any number which is ending with 1 or 9, if you take square of that particular number, then that square will actually end with unit place equal to 1. So this is another property. So similarly to this property, there is one more property where if the square root or if any number which is actually ending with 4 or 6, then that particular number's square. So if you take the square of that particular number, then the square will actually end with 6. So let us take few example. So 4 is actually ending with 4. So the square of 4 will actually end with 16. So you can actually see here this particular 16 is ending with the number 6. Similarly, if you take 16 square or if you take 6 square, this particular 6 square will be having 36 as its answer. So here also you can see unit place 6 is actually ending. Here also square of 6 is also having 6 in its units place. So if you take 14 square, so the answer for 14 square is 196. Similarly, if you take 16 square, the answer for 16 square will be 256. So now you can see any number which is ending with 4 or 6, 4 or 6, then its square, if you take square of that particular number, then that will actually end with 6. That will actually end with the unit place equal to 6. Here in previous property, if a number has 1 or 9 in its units place, and if you take square of that number, then that particular square will be ending with 1. That's what you have seen here. You can see 1, 9, 1, 9, 1. So the numbers are ending with 1 and 9. And their squares are ending with 1, 1, 1, 1. So here also, if numbers are ending with 4 and 6, then its square number will be ending with 6 alone. So here you can see 4, 6, 4, 6. So numbers are ending with 4 or 6. But its square numbers are ending only with 6, 6, 6, 6. That means if a number is ending with 4 and 6, if you take square of that particular number, then that square will also be ending with 6. And coming to the next property in this particular square chapter, if a number is ending with 1 0, then its square number will be ending with 2 zeros. If a number is ending with 2 zeros, then its square will be ending with 4 zeros. If a number is ending with 3 zeros, then its square number will be ending with 6 zeros. So this is one more property. So now let us take example and understand this. So if 10 is there, then 10 square will be equal to 100. So now you can see 10 has only 1 0 in it, but 100 has 2 0 in it. So the moment you take square of a particular number which has only 1 0 in it, now the square contains 2 zeros. Similarly, if you take 20 as example, 20 square will be 400. So here also you can see 20 has only 1 0 in its units place, but 400 has 2 0 in it. That shows if a number is ending with 1 0, then its square will be ending with 2 zeros. If a number have n zeros in it, then its square will be having 2n zeros. So 2 times the number what is there will be there in square. So if I take another example, let's say 100 square, here you can see 2 zeros are there in this particular number. So its square will be having 4 zeros. That means 100 square is equal to 10,000, and 10,000 is actually having 4 zeros in it. So now you can clearly see number ending with 2 zeros have 4 zeros in its square. Similarly, if you take 1000 square, the answer for 1000 square will be 10000000. So 10 lakh will be the answer for 1000 square. That means you can see here 3 zeros are there, and here you can easily see 6 zeros are there. So if any number of zeros are there for a particular number, and if you are taking square of that number, then the square of that particular number will contain twice the zeros which was there in that particular number. So 10 has only 1 zeros. Square of 10, that is 100, will be having 2 zeros. So 100 has 2 zeros. Square of 100 will be having 4 zeros, that is 10,000. Similarly, it goes on like this. Any number you take which is actually having 0 in it, like which is actually ending with 0, you should see how many zeros are there, with how many zeros that particular number is ending, and you should actually predict that if you perform square operation on that particular number, if you take square of that particular number, then the ending of that square number will be having zeros, twice the zeros which this original number was having. So this is one more property in this particular square. Coming to the next property, there is again some fun game with numbers. So you can actually take square of natural numbers. So let's start from 1. So if I take square of 1, 1 square will be equal to 1. 2 square will be equal to 4. 3 square will be equal to 9. Similarly, 4 square will be equal to 16. 5 square will be equal to 25. So here you can see I have taken square of natural numbers starting from 1 till 5. So if I actually perform subtraction between the higher square number and its previous square number, so you can easily see there is some difference in it. So let's say I am actually making subtraction between 4 and 1. So 4 minus 1 will be 3. So now if I make 9 minus 4, like I am taking 9 and I am actually subtracting with the previous perfect square number. So these are all perfect squares. 1 is perfect square, 4 is perfect square, 9 is perfect square, 16 is perfect square, 25 is perfect square. That is because their square root has natural numbers as its result. So there is no decimals or fractions here. So 1 is perfect square. After 1, the next perfect square is 4. Because after 1, the next number is 2. So if you take square of 2, it is 4. So there is 2 and 3 which is there in between these two perfect square. So you can easily see 1, 2, 3, 4. Among 1, 2, 3, 4, 1 is perfect square and 4 is perfect square. And there are two numbers which are left out in this in between these two numbers. Similarly, if you actually move on, if you make 9 minus 4, then you will get answer as 5. So similarly, I'll perform one more operation like 16 minus 9. So 16 minus 9 is actually equal to 7. Similarly, if I make 25 minus 16, then 25 minus 16 is actually equal to 9. That shows if I do 4 minus 1, we have two numbers in between these two perfect squares. Answer is 3, but we have two numbers in between these two perfect squares. Similarly, here when I make 9 minus 4, then there are 5 minus 1 numbers. That is actually 4 numbers in between 3 square and 2 square. So in between 3 square and 2 square, there are 4 numbers. In between 2 square and 1 square, there are 2 numbers. In between like 4 square and 3 square, there are 7 minus 1 numbers. That is 6 numbers. So you can see here, if you actually subtract these two perfect square, the immediate perfect squares, then whatever number you will get, you should actually subtract 1 from it. Then you will get how many numbers are there in between those two perfect squares. How many numbers are there between 10 square and 11 square? Then you can easily tell how many numbers are actually present in between 10 square and 11 square. You can actually take 11 square and 10 square. You can take 121 minus 100 because 11 square is 121, 10 square is 100. So 121 minus 100 is 21. So if you subtract 1 from this 21, then it will be equal to 21 minus 1 is actually 20. So 20 numbers will be there in between 10 square and 11 square. So now, based on this, we can actually write a particular general formula for this. So let's say n square is one perfect square, n plus 1 square is another perfect square. So I am taking where n is actually a natural number. So here you should always remember you should take natural numbers only. So n plus 1 whole square is one perfect square and n square is its previous perfect square number. So now if we actually subtract the perfect square, one particular perfect square with its previous immediate perfect square, then what will be the result? Let us see what will be the result. So n plus 1 whole square minus n square you should do. So n plus 1 whole square is actually a plus b whole square. It is in the form of a plus b whole square. So a plus b whole square is equal to a square plus b square plus 2ab. So that actually shows this particular formula can be applied here. So here a is n and b is 1. So just substitute that. So it will be n square plus 1 square plus 2n into 1, that will be 2n. Minus n square is there along with this. So minus n square you can write here. So here minus n square and plus n square gets cancelled each other. So finally you will be left out with 2n plus 1. So if I give a higher number, so let's say if I give 10 square and 11 square, and if I tell you to calculate numbers between 11 square and 10 square, these are pretty small numbers, so easily you can find out the square of this and you can tell 121 minus 100 is equal to 21. And 21 minus 1 is equal to 20. So 20 is the number, like 20 numbers are actually there in between 10 square and 11 square. You can easily tell that. But now if I actually ask you some bigger number, like 144 square and 145 square. So if I give two consecutive natural numbers square, then how can you tell how many numbers will be there in between these two perfect square? Now you should actually take the square of 145 and you should actually take the square of 144, subtract them, and then you should find how many numbers are there in between them. But it is actually tedious process, because now you should do 145 into 145 and you should actually find out the answer, and you should do 144 into 144 and you should actually find the answer. Then you should actually subtract these two, and then whatever result you will get, you should subtract that by 1, and later you will get the answer. Similarly, what you've done here, like you did 11 square and 10 square, like 121 and 100. So you just subtracted 121 with 100, that is 11 square minus 10 square. So you got 21 as the answer. You just subtracted 1 from 21 and you got 20 as the answer. So 20 is the number, like 20 numbers are actually there in between 10 square and 11 square. But now if I give this big numbers, then again you should find square of these two numbers and you should subtract that and you should do all those tedious process. So 2 square is 4, 1 square is actually equal to 1. So if you do 4 minus 1, you will get 3 as your answer. But when you write numbers like this, 1, 2, 3, 4, so 1 is perfect square, 4 is perfect square. There are only two numbers there in between these two perfect square. So you should actually subtract one number from this 3. So when you do 3 minus 1, you will get answer as 2. So now you can easily see two numbers are there between these two perfect squares. So subtracting with 1 is very much important. Now when you actually make n plus 1 whole square minus n square, you actually got 2n plus 1. So this 2n1 plus 1 should again be subtracted with 1, so that you will get those many numbers will be there between two perfect squares. So 2n plus 1 minus 1 will be equal to 2n. So now you can easily solve this question. Like what are the numbers? Like how many numbers are there in between 145 square and 144 square? So now you can see 145 square minus 144 square. You need not do this because this particular thing will take your time. So you can easily see what is n. So the lower number among these two numbers is actually n. So you can easily multiply that with 2. So 144 into 2 you can do. So what is 144 into 2? 4 2s are 8, 4 2s are 8, 2 1s are 2. So 288 is there. So that you should actually remember. So 288 numbers are there in between 144 square and 145 square. So this is actually one property. Because based on this property, we will be solving exercise problems. So in exam, if you want to solve these particular exercise problems or any other problems if they give in exam, so if you want to solve, then knowing all these properties is very important. Only based on these properties, you can easily tell what is the answer for that particular question. So at that time, your time can be saved in exam. So coming to the next property, if you add consecutive odd numbers, if you go on adding, then you will always get a perfect square number. For example, 1 is actually a perfect square number because 1 square is 1. So now, if I add 1 plus 3, the next consecutive number after 1, the next consecutive odd number after 1 is 3. So if I add 1 plus 3, I will get 4. 4 is actually perfect square because 2 square is actually 4. So similarly, if I add next consecutive number for this, that is 5, then you will actually get 9 as your answer. So 9 is also a perfect square because it can give you 3 square, where it can give a natural number square. That means 9 is a perfect square, 4 is a perfect square. Now if I add 4 odd consecutive natural numbers, like starting from 1, then 1 plus 3 plus 5 plus 9, next consecutive odd number is 7. When you add these odd numbers, then you will get 4 plus 5 is 9, 9 plus 7 is 16. 16 is again a perfect square because 4 square is actually 16. Similarly, if you add next consecutive odd number starting from 1, then it will be up to 9. So 1 plus 3 plus 5 plus 7 plus 9. So that is actually equal to 25. This will be also a perfect square because 25 is actually 5 square. So here you can see, so if you go on adding odd numbers starting from 1, you should always start from 1 and you should go on adding odd numbers then you will go on getting perfect squares. So this is actually one beauty of numbers. So this is one property of this square. So coming to the next property in this particular square chapter, any perfect square can be expressed as the sum of two consecutive natural numbers. For example, 9 is a perfect square. 9 can be expressed as 4 plus 5. So 4 is a natural number, 5 is a natural number. So these two, like 5 is the immediate natural number of 4. So that shows 4 and 5 are consecutive natural numbers. So any perfect square can be expressed as the sum of two consecutive natural numbers. So here you should not get confused by imagining that sum of any two consecutive natural numbers will give you perfect square. No, that is actually wrong, because now if you add 2 plus 3, then it will give you 5. 2 and 3 are consecutive natural numbers, but when you add that, you are getting 5, which is not a perfect square. So sum of consecutive natural numbers, two consecutive natural numbers, always it is not a perfect square. But you should actually see this property in a reverse manner, where perfect square can be actually expressed in the form of sum of two consecutive natural numbers. Here 9 is expressed as 4 plus 5, where 4 and 5 are consecutive natural numbers. But you cannot take any natural numbers of your wish. You should only take those natural numbers which can give you perfect square. Or you can tell this property in a reverse way, where every perfect square can be expressed as the sum of two natural numbers. So sum of two consecutive natural numbers. Consecutive is the word which you should actually remember. 25 can be expressed as 12 plus 13. So here also you can easily see sum of two consecutive natural numbers is giving a perfect square. Not all the time sum of two natural numbers will give you consecutive natural numbers will give you perfect square. It is, this property states perfect square can be executed as sum of two natural numbers, consecutive natural numbers. So this is what property is saying. So you can express this particular perfect square as the sum of two consecutive natural numbers. So 12 plus 13 is giving you 25, 8 plus 9 is giving you 16, 4 plus 5 is giving you 9. And, similarly, 2 plus 3 will not give you perfect square. 1 plus 2 will not give you perfect square. 4 plus 5 will not give you perfect square. But if you take a perfect square, then that perfect square can be expressed as sum of consecutive natural numbers. Two consecutive natural numbers. So that is what this property is trying to tell you. So coming to the next property, here also some number fun is there. So if you take 1 square, if you take 11 square, if you take 111 square, if you take 1111 square, if you take 5 1 square, if you take 6 times 1 square, then if you want to calculate the square of this particular number, then this goes in a particular pattern. So that is actually 1 square will be equal to 1, 11 square will be equal to 121, 111 square will be equal to 1, 2, 3, 2, 1. 1111 square will be equal to 1, 2, 3, 4, 3, 2, 1. Similarly, 11,111 will be equal to 1, 2, 3, 4, 5, 4, 3, 2, 1. Similarly, 1,11,111 will be equal to 1, 2, 3, 4, 5, 6, 5, 4, 3, 2, 1. So you should always remember how many ones are there. If this particular number is having only 1 in it, then you can actually count how many ones are there in this particular number. So that many times you should write a natural number. For example, here 1 is there 2 times. So you should write natural number starting from 1 up to 2. Now here in this particular number there are 3 1 in it. So only numbers which have only 1 in it, and you should actually count how many ones are there in that particular number, and that many times you should write a natural number in ascending order and descending order. So here 3 times 1 is there. So I have written natural number up to 3. 1, 2, 3. That is in ascending order. Now again you should actually you should write that in descending order. So 3 is already written. Next number will be 2, 1. Similarly, here 4 numbers are there. So up to 4 natural numbers starting from 1 you should go. So 1, 2, 3, 4 and 3, 2, 1. So from 4 again it will be descending. So similarly, it will go on like this. So pattern will go on continuing like this. So this is actually one fun game in numbers. So now let us actually learn how to find square of a particular number. So let's say we have, let me take an example 29. So what is the square of 29? So if you want to find the square of 29, then there is a method for this. So write 29 square as 20 plus 9 whole square. Here you can easily see this is in the form of a plus b whole square. So that will be actually equal to a square plus b square plus 2ab. So now you can easily write this particular number as 20 square plus 9 square plus 2ab is actually 2 into 20 into 9. So now you can easily solve this because 20 square has one 0 in it. Just take the square of 2. Square of 2 will be 4 and just take the square of 0. So I actually told in one of the property that if a number has one 0 in it and if you take square of that particular number, then its square number will be having twice the zeros. So here 1 0 is there in this particular 20. So in the square it will be having 2 zeros. So 2 square will be 4 and 2 zeros followed by 2 zeros. Because here 1 0 is there, you are putting 2 zeros here. So square of 20 will be 400. So this is very easy to calculate. So we are actually splitting that 29 into 20 plus 9 and taking whole square and substituting the formula a plus b whole square in it. So you are getting the answer for this. 9 square is very easy because 9 into 9 is 81 plus 2 into 20 is 40. 40 into 9 is 9 4s are 36. So 360. Now you can easily perform this particular addition. So 400 plus 360 will be 760. 760 plus 81 will be 841. So the answer for 29 square will be 841. Similarly, if we take 42 and if you want to find square of 42, you can easily do it by splitting that 42. So 42 square will be equal to 40 plus 2 whole square. So that will be actually in the form of a plus b whole square. So this is in the form of a plus b whole square. That is actually equal to a square plus b square plus 2ab. So here a is 40 and b is 2. You can easily solve this particular problem where 40 square plus 2 square plus 2ab. ab is actually 40 into 2. So now you can easily solve this. 4 4s are 16. So 1 0 is there. So now it will be for 2 zeros. So 16 followed by 2 zeros will be the square of 40. Plus 2 square is 4 plus 2 into 40 is 80. 80 into 2 is 160. So 164 plus 1600 is actually 1764. So this is the square root of 42 square. So there is one more concept in this particular chapter which will actually discuss about Pythagorean triplets. So what do you mean by Pythagorean triplets is that, so there will be three natural numbers where if you actually square the two natural numbers, then that will be equal to the square of the third number. So here I will give one example as 3, 4, 5. So all 3, 4 and 5 are natural numbers. The two lowest numbers among these three numbers. So in these three numbers, 3 and 4 are the lowest numbers. So when you square those numbers and add together, then that will be equal to the third highest number which is there among those three numbers. That is, it will be equal to 5 square. There is one more Pythagorean triplet which is actually 6, 8, 10. So among these three natural numbers, the lowest natural numbers are 6 and 8 among these three natural numbers, only in those three natural numbers. So when you actually take the square of those two and when you actually add, that will be actually equal to the highest number square, that is 10 square. So you can cross verify this. What is 3 square? 9. What is 4 square? 16. So 9 plus 16 is 25. What is 5 square? 5 square is actually equal to 25. This will actually confirms that 3 square plus 4 square is actually equal to 5 square. Here also you can cross verify. 6 square is 36, 8 square is 64, 10 square is 100. So 36 plus 64 is actually equal to 100. So the natural numbers, three natural numbers, if they are actually satisfying this particular rule, where you are taking two lowest numbers among those three natural numbers and you are squaring that and adding together, if you are getting the third highest natural number, square of the third highest natural number, if it's satisfying this particular rule, then those three natural numbers are known as Pythagorean triplets. So there is a general formula for this particular Pythagorean triplets. For any natural number which is greater than 1. So here m is actually a natural number. So for any natural number which is actually greater than 1, 2m, m square plus 1, m square minus 1 will always act as Pythagorean triplets. So this you can actually cross verify by taking example. So let's say I am taking 3 as my number. So I am taking one example where m is actually equal to 3. Then what is 2m? 2m will be 6. What is m square plus 1? M square plus 1 will be 3 square plus 1. So 3 square plus 1 is actually 10. So what is m square minus 1? That will be 9 minus 1, that is 8. So you can clearly see we are getting a Pythagorean triplet. So here 2m m square minus 1 acts as lowest numbers and m square plus 1 act as highest number. So these three numbers will account for Pythagorean triplets. You can take any number. So for example, we'll take another number and cross verify. So let's say m is actually equal to 5, which is actually greater than 1. So 2m will be equal to 10, m square minus 1 will be equal to 24, m square plus 1 will be equal to 26. So you can cross verify this. These two are lowest numbers, where 10 square plus 24 square. So when you do this, that should be equal to 26 square, and it will be equal to 26 square. So here 10, 24 and 26 acts as Pythagorean triplets. We will just verify whether they act as like Pythagorean triplets or not. What is the value for 10 square? 100. What is the value for 24 square? You can do it as 20 plus 4 whole square. So 20 square is 400, 4 square is 16, 2ab, that is 2 into 20, 2 into 20 is 40, 40 into 4 is 160. So 160 plus 400 is 560, 560 plus 16 is 576. So you are getting 576 as for your 24 square. Similarly for 26 square, it will be 400 plus 36, that is actually a plus b whole square. Like I am just doing it as 20 plus 6 whole square. So 20 plus 6 whole square will be equal to 20 square, that is 400, plus b square, that is 6 square, that is 36, plus 2ab, 2 into 20 into 6. So 6 2s are 12. So 120 into 2 will be 240. So 400 plus 240 will be 640. 640 plus 36 will be 676. So the answer for 26 square will be 676. So now if you add 576 and 100, it will be 676, which is actually equal to 676. So this actually confirms that 10, 24 and 26 are actually Pythagorean triplets, where you have taken m as 5. So that is how you can cross verify that 2m, m square minus 1, m square plus 1 are acting as Pythagorean triplets. So 2m, m square minus 1 and m square plus 1 is a general formula for Pythagorean triplets, where m should be greater than 1 and m should always be a natural number. So this is all the explanation related to squares. Similarly, in my next video, I will be teaching exercise 5.1 and exercise 5.2. Followed by that, I will be teaching what do you mean by square roots. So in this particular squares and square roots, I will be making 3 videos, out of which this is part 1 video. So followed by part 1 video, you will be having part 2 video based on exercise problems and also based on square roots, and also exercise based on square roots. To understand squares and square roots chapter properly, you should go through all these 3 parts. So this is actually part 1 video, and here I am ending this part 1 video. So like this, I will be uploading more and more physics, chemistry and mathematics videos in this particular YouTube channel. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel and stay tuned with my channel. Thank you.